This episode is sponsored by Kendo UI. Kendo UI allows you to build better apps faster. They have a comprehensive library ranging from data grids and charts to buttons and sliders. Plus, you can use their components as plain JavaScript as well as in Angular, React, and Vue. They have a large collection of customizable popular themes like Bootstrap and Material. Go check them out at reactroundup.com/KendoUI. Hey everybody, and welcome to another episode of React Roundup. This week on our panel we have Lukasz Reisz.
Hello from New York.
I'm Charles Max Wood from devchat.tv. And this week we have two special guests. We have Charles Lowell.
Hello, hello.
And Taras Mankovski.
Yes, hello. From Toronto.
Yeah, it only took me 2 tries.
That's good.
I guess I should mention I'm calling in from Corrales, New Mexico, since everybody else gave their location. It's beautiful here.
Nice. Is that where you live, or are you visiting?
Yeah, no, that's where I live.
Awesome.
So, was in Austin for a while, most of my life, and just came out here last December. So,
yeah, a good friend of mine, Brandon Hayes, used to work at Frontside. So,
Yep.
Do you want to introduce yourselves really quickly before we get going, and that way people can go look you up and see how awesome you are?
Sure. I guess I can start off. So my name's Charles. I'm the principal engineer and founder at Frontside. I've just loved to code and love programming and love everything about it. Statically typed, dynamically typed, love it.
I'm Taras. I work with Charles. I joined Frontside because of Charles' love for code. So I think we have a pretty cool team of like very diverse people, pretty kind of comprehensive personalities, all very dedicated to code and also dedicated to being nice people. So that's it's been pretty great. And so I'm a senior software engineer at Frontside.
Awesome. And you guys wrote a little state management library called Redux. I'm just kidding. So you wrote this Microstates, which is a state management library. I think most of the examples I've seen are React, but it looks like it's framework agnostic. Do you want to just kind of give us a rundown of what it is and why we need yet another state library besides Redux and MobX and some of the other ones that we've heard about?
So I think Microstates is kind of different in many ways. I think we try to do what a lot of libraries don't, simply because we believe there's a more comprehensive solution necessary to handle state better. So like one of the things that is unique about Microstates is that you don't need to write common operations that you would write for almost every other tool. So if you need to increment a number, you don't need to increment the number in Microstates because you don't need to write how to increment a number because incrementing a number is part of the number type, and a number type can be incremented as part of the mechanisms that are built into Microstates. And that's kind of like the starting point. And from there, we build up to much more comprehensive mechanics for actually composing state. Charles, you want to take it from here?
Yeah, I think it's worthwhile dwelling on that point because whether you're using MobX or whether you're using Redux or whether you're just using set state, if you say you have some action that's going to let's say show a modal dialog or something like that, you have a Boolean value. Is it showing or is it not? You're going to have to write the reducer that's going to take the current value and return true if it's false and false if it's true. And you see that in every example of state management out there. You kind of see these same, whether it's an action or called an action or a reducer or, an event handler, they all kind of do the same thing. They, are manually maintaining this value. And Microstates takes the approach, it's like, hey, it's a Boolean value. There's a set of operations that you can do on that Boolean value it's a closed set of operations that is known ahead of time. You do not, as a programmer, need to be manually doing that. That should be provided for you. And so kind of the Microstates approach is it's centered on type. And so you say what type of data you have, and then the operations just shake out. And so what was kind of once what you would consider a state management solution today kind of in the microstates world is more boilerplate.
Yeah, and I think it's kind of worth noting that incrementing a number is really easy, and everybody knows how to do it. So the actual activity itself is not difficult, but our applications are composed of hundreds, sometimes depending on size of applications, thousands of little values that are used throughout your application and the user interacts with. And so, what starts off as being a really simple value, when you compose them into this, into more complex data structures that represent the state of your application, transitioning that Boolean value that is deep, 3 levels, that's nested 3 levels deep, becomes much more complicated. And if your requirements change, then now you had one entity or one component where you could enter some data, and now your requirements are like, oh well, actually we want to be able to have multiple of these things. So now you have a data model. You have a kind of a piece of data that represented a single entry form. Now you have multiple of these forms on the page, and now you need to represent these in an array of entryable components, and then you need to be able to check their state, so you can do something very specific. Like when you start to kind of accumulate these requirements, the complexity starts to grow really fast. And when you have to manually transition, small, simple operations, your complexity just grows and grows until it becomes really difficult. And then you just get really good at managing these things. But there's a lot of things to manage both in your mind and in your code.
So one thing that I've seen just looking at the README and kind of, I haven't had a chance to play with this yet. I wanted to after your talk at the React Developer Summit, but I have a lot of things going on. And anyway, it seems to be, how do I put it? It looks and feels a lot to me more like object-oriented approach, where some of the other approaches that I've seen in like Redux and MobX seem to be a little bit more functional or reactive. Is that a fair characterization, or am I missing the point somewhere?
I think that's actually a great observation, because it feels object-oriented, and yet it is absolutely purely functional. And that is exactly the aesthetic that we were going for. Because if you managing change in a object-oriented fashion or a mutable way is very easy. Objects compose very easily. So it's very simple to say, I want to, like if I've got a complex data structure that's maybe 3 levels deep, I can just say, I want to set this field, 3 levels deep inside it, and then it's done. Right. And if you have an object-oriented approach, or if you have a mutable approach, that's very easy. And it's one of the appeals of that kind of paradigm. On the other hand, if you want to do it in a purely functional way, like if I've got, some data structure, let's say I've got, we'll use the blog post example. I've got a blog that has a list of posts, and each post has an author. If I want to set a field on that author, I have to basically pick apart that data structure, map the author field, and then put it back together. And so when you're dealing with pure kind of functional code, you do a lot of destructuring and then restructuring to encapsulate that value back again. And so if you're doing things in kind of a pure, immutable, functional way, you can, as you start to deal with complex data structures, it can get unwieldy, and a lot of your code, the signal to noise ratio kind of deteriorates, because you have a bunch of your code that's dealing with picking apart the data structure and putting it back together, picking it apart and putting it back together. Microstates actually uses a technology that's kind of, I think, becoming more pervasive. It actually originated in Haskell, or at least that's where I found out about it, called lenses. And it uses lenses internally extensively to basically abstract the structure of the data so that you can work with it in an immutable, functional way. And I know I'm kind of hand waving and throwing out a bunch of like catchphrases, but that's basically what lenses allow you to do. So I can say, I can have the appearance of an object-oriented API, but in fact, I have an immutable, purely functional API. So that's what Microstates provides. So it feels very familiar to JavaScript developers, but you are able to realize all of the benefits of having a single immutable atom in your application.
Since you talked now about Haskell and lenses, I was having like that in my mind, and the use of immutability. I was going to ask, what were your inspirations for Microstate? You just now said Haskell and the lenses, but the first time I looked at it, I thought a little bit about like Clojure and the immutable maps and vectors that they have, that you kind of like go deeply like into them with some complex setters and getters that could be seen as lenses. What are the inspirations for Microstates?
So I can tell you kind of the personal journey that gave rise to Microstates. Started for me, I guess, back in 2015. And it was when I was working primarily in Ember, and which has a very nice composable object system, but it's mutable. So it's very similar to like MobX. And I was trying to build a form library that was kind of a general purpose form library that had, it had validation and it had history and dirty checking and, all these things. And I just couldn't quite get it to work. And so I kind of went out looking for other solutions, and I fell across this. I don't know if anybody's ever heard of this library called Ohm, which it's not in wide use, but I think it was kind of in many ways the inspiration for, I don't know this for certain, but it's very similar. It was the first time I was introduced to the kind of the Redux pattern or the Elm architecture where you have a single atom. And so an Ohm application, and it's a ClojureScript framework. It's ClojureScript in React. And the idea is you have a single atom of state that is always rolling forward, and your view is completely and totally derived from that. And so that kind of was the introduction to immutability. And so I really perceived the value in this because a couple things shook out of my usage of Ohm, or a couple things clicked for me. And one is that being able to peer, not just for like having time travel debugging, but when you're working with objects that are changing over time, which is, I think, why you run into it with a form library in particular, is a form is a model of change. So, unlike other areas of application where you can kind of get away at looking at your object as it is now, or your model as it is now, with a form, you are literally capturing the act of changing it from one state to another. And so whether you're dirty checking a field, whether you're dirty checking the entire state of the form, you need to be able to look at what was and what will be and make decisions based on that. And so Ohm never threw away information. And so you were explicitly able to look, and it was very easy to do those kinds of things. So I was very much sold on immutability. It was also very easy to debug because you had a very clear log of what happened. Anyway, but I was used to working in Ember, where you have these nice composable objects, and I very quickly started to run up against this complexity of if you're working with immutable data structures. And so I started basically using POJOs, immutable POJOs inside my Ember applications. And I started all this very quickly running up as I would have forms that had a list of fields, and each field had the value and type of it. Like the POJOs became very complex, and a large percentage of them was dealing with just copying data around and cloning the data and the same problems that anybody who's ever wanted to work with complex immutable structures runs into eventually. I actually this is right around 2016 2017 timeframe. I don't know when we found lenses and when we started.
It was three versions. It was I think almost December of last year because this is the current version of Microstates is it's I think internal rewrite number 6. So at every stage we've been
there's been a lot of research.
Yeah, there's been a lot of research. So we've been realizing what it is that we what we always started off. It's always been from day one started from the ergonomics. It had to feel right, but how do you make it feel right and then satisfy all the other requirements? One of the requirements along the way was how do you make sure that you have structural sharing that works correctly, so that when you use it in React, for example, your components don't re-render necessarily, right? So that was one of the rewrites.
How do we make it lazy?
Yeah, how do we make it lazy? And then how do we make it tiny? How do we make it, so there's all these things that every time that we got like one step closer, we were like, okay, there's architecturally something missing, and went back and rewrote it. And I think this is one of the things that's I would say is really unique about microstates is that unlike other solutions which come from like insight that kind of a light bulb moment, and there was a lot of opportunities and there's a lot of light bulb moments in microstates, but it's really designed. It's really designed to ease the process of development. It's not just it's trying to solve a problem, but it's also trying to solve a problem in a way that eliminates categories of problems.
Mm-hmm. Yeah, I think that's the key insight there is that we had a goal in mind, and we kept on, basically after this initial experience, of really getting a lot of insight from the functional programming community, we kept that goal in mind and just kept on dipping back into the candy jar, so to speak. And so over the process, we actually had to learn about all of the kind of the functional mumbo jumbo, functors and semi-groups and monads and blah, blah, blah. It's actually all in there. But the goal was never to use those things. The goal was to have the most ergonomic API for managing state from the developer's perspective. And then whatever tools we need from the functional world to make that happen, we borrowed from freely.
So I kind of want to get to some of the practical aspects of this. So let's say that I'm building a React application and I decide, this microstates thing looks really great. I want to pull it into my application. What does that look like? Do I just npm install it, tell Webpack that it's there, and then start creating types? Or
that's pretty much it. So essentially, we have right now a React bindings library, which all it does is it's a component that takes a type and a value, and it will create an object for you, a microstate object, and then you can use the microstate object, you basically can pass it to children, and then that object has state on it, and from that object you get the transitions that you can invoke on that state. And so when the programming paradigm is you're essentially like, oh, this is the next part that I'm going to work on. I'm going to add the state that I need to my microstate, and then that makes that state available in your application. And then because of and this pattern we looked at the React implementation has pieces from unstated, the delivery of the mechanism of delivering context to the component tree, that is the same mechanism that was implemented by the creator of Unstated. So some of the inspirations around the ergonomics of use in React are very kind of conventional. There are some things that we don't use in React. I mean, in the React bindings right now, we don't have a connect function, which I think would be something that would be really easy to implement. It's just it's not a paradigm of programming that we tend to use, and so it hasn't been our priority. But anyone who is familiar, anyone who really likes Redux, can get the same kind of ergonomics as they would with Redux if they want to. It's just that they don't have to do any of you don't have to write reducers. That's one, that's kind of one big perk. There's a lot less wiring that you need to do because microstates, taking a bigger, broader approach, is able to do more optimizations for you automatically because it's in many ways, microstates is a kind of combination of if you were to look at it in the React world, it'd be kind of similar to a combination of Redux, Immutable.js, and Reselect, all packaged in one tiny package that's I think a fifth of the size of those three libraries combined. But ultimately, I think where we're going is to provide people with a primitive that they can use to describe their data that they can take anywhere. Whatever framework you use, you'll have the same kind of developer ergonomics across all the frameworks. Because ultimately, what we want microstates to be the most ergonomic way of working with state for component applications.
Right, and I think we are really, really focused on the state and nothing but the state. So, you don't even need to use the React bindings. If you didn't want to, you could actually just have a component that in its constructor instantiated a microstate, and then mapped handlers for the transitions to either use it as an observable, because you can trivially generate an observable off of any microstate, or just use the microstate and handle the transitions manually, if that's what you wanted to do. I think you probably would want to use the React bindings, but it's designed to be, it really is designed to be a building block, so that you can take this, and it does immutable state transitions really, really, really well and elegantly and composably, so that you can take the types that you've defined and compose those into other types and put it anywhere and build your own tools around it, should you choose. I think we're still in the early days of seeing what are the best practices. It's still a story that has yet to be written.
I have one question about this best practice part that we're still gonna understand. So when you think of, I remember OM being in Redux applications being like a single atom of state that is global, and then you use on your whole application. But the more modern usage of it is having also local state in places where it makes sense. How would you think microstates enters that picture? It's do you believe in single big composed states, atoms, or smaller ones? What do you think is how have been your experience with it?
I think part of the design of microstates is that we want it to be something that people can reach for, as the level of complexity goes from something very trivial up to as complicated as they need to go, and give them flexibility. I think one of the challenges that you have with other solutions is that even though they give you, they might give you some APIs that are kind of similar, but they might not be as comprehensive in terms of where you can use it. For example, if you look at Redux is really great for global state, or for global state for a specific branch of a DOM tree. But what usually tends to happen is that people will, if you want to create if you want to create something that you can share with others, you're going to create a component that is going to inside of it have Redux, but the actual composition happens at the component level. What we would like to do is, because you could do that with microstates, but what we'd like to do is give you the option of saying, okay, well, you can use the component exactly the same way, but you can also take the model and then you can compose that model into a bigger model. And now you can, instead of, so what that gives you is it allows you to now compose the state of the component. Now the component is going to receive the state from the outside, and now you can manage the state of that component from its context without having to kind of change the architectural layers, where you're going from working with the model. Now you've got you can actually just continue to work with the model layer without having to think of what happens when you have these multiple components rendering and they have different render cycles, and figuring out the glue between these components becomes unnecessary because you were able to just take the state from the component and move it up, lift it up into a higher component or a higher model, and then manage it at a higher level.
Yeah, I think another way to say it is by essentially removing the cost of composition. So you get what microstates gets you is, if I have some component that's got local state, if you were to store that as a microstate, if you wanted to, plugging that into a global tree would be trivial, or keeping it apart. But what you don't want to do is get into a situation where you're handling events coming out of this component and then pushing those events into some other store to keep these two things in sync. With microstates, you should just be able to take this state and just say it's now part of this tree, and now that tree can transition seamlessly as one atom, and you could then take that tree and put it into a larger tree, and so on and so on. And by kind of basically reducing that cost to effectively making it free, it means that you have options to handle the state. The state's kind of under your control.
Deploy more, pay less with DigitalOcean, the simplest all-in-one cloud computing platform for developers. Scale and run cloud applications faster and more efficiently with effortless administration tools to robust compute, flexible configurations, networking services, real-time alerts, and rapid provisioning, while enjoying industry-leading price to performance with a flat pricing structure across all global data center regions at any usage volume. Spend more time building better web apps and less time worrying about managing infrastructure with DigitalOcean. Build your next app on DigitalOcean. Get started with a free $100 credit at do.co/roundup.
Yeah, I like this answer. This is very interesting. One other thing that I think about and it's a recent thing I've been looking at, and I saw that you addressed in your README. I'm also a big fan of strong type languages. Since I looked at Elm the first time, I was hooked, and the way that you can think about like the states, the actions, the transitions between it. And now recently I've seen this interesting finite state machine thing comes from more like dynamic languages. I see like in Clojure, and now in JavaScript it's starting to. And one aspect I like of it that I believe it's even stronger than the strong typing solutions is that there is like a very interesting like state design thing that it's even like a good communication tool with people that are not developers. How do you think microstate fits in this? What would be the benefits, or does it play together?
Yeah, so I think there was actually a critical piece of the story that I left out when I was kind of telling it originally, and this is really where Taras and I came together on this, is over the conception of using state machines to express your UI. That was actually very much one of the original kind of conceits of microstates, and it's where the kind of the state word is like they're little state machines that you can compose. As a front end shop, we're already familiar with state machines and use them in our design of saying, okay, here's this workflow of this UI is going to transition from this state into this state, and at any given time, it's going to be in one of these states, and there's a discrete number of transitions. And as it turns out, that there's a very clean mapping between state machine and type, where the type corresponds to the state. The methods correspond to your state transitions, and then the actual instance variables or kind of the content of your object just represents just that, like what the content of that state. And then as a design tool, it's a very straightforward process to take a state machine on paper and then transcribe it into a microstate. It's just for every state you have a class, and then you have a method for every transition. And so it's a great design tool. And then for actually being able to go the other way of having a microstate and then being able to generate a state chart for it, we're actually not quite there yet, but that is one of the eventual goals. But what you need is a declarative way to describe your transitions. And that actually maps very cleanly to type annotations. Like if you imagine Haskell type annotations, or maybe even like TypeScript type annotations, or some sort of type annotation system, you can describe in the abstract, I'm going from this state or this type over to this other, through this transition, the arrow is the method, and then the return value is the type or the destination state. And so there's actually this very clean mapping between type and state machine. What's interesting is, one of the things we're finding is that we're, implementing a lot of the mechanics that you see in compile time type systems and making them available at runtime, and so that your application can harvest all of that rich information.
I think we don't really talk about states very much right now because there's been a lot of other things that we needed to deal with. But I do believe that the state machines are going to be something that we're going to do a lot of in the near future. But I think one of the kind of valuable goals for us has always been to give people tools that will just work correctly for them. Like they will steer them in the right direction. I think one of the things that was really interesting about the research that we were doing around state machines is that when you look at state machine implementations, or if you look at state machines APIs, like what a lot of times what will happen is they'll say, and this is how you can transition from one state to another, and then some stuff happens to values, And it's just like, it's kind of left really vague. But the problem is that very often your state transition, so your state change, is meaningful in the context of the value that's actually moving with your state transition. And so it's actually, to have a solution that does state machines, but that does not actually address the value change, it leaves room for challenges and leaves room to have those challenges be resolved by the user, by the developer, as opposed to having it being part of the consideration. There is actually a lot of my opinions around design of these things are based on the mentoring that I do, because I think as a mentor I'm kind of at a point now where I've helped a lot of people learn, but I need to make tools that are going to help them that is going to kind of shorten that gap, reduce the amount of time and help people who are less experienced be more productive. I think that helps everyone on whatever spectrum of development, whatever level of experience you have. But one thing that I noticed from people, and this actually applies both for intermediate or even sometimes senior developers, sometimes you lose track of what needs to change. So I think if you look at an application, and if you look at set state, and if your set state is changing like more than one or two properties at any given point, like if your set state is affecting 7 values, probably what's happening is that you lost track now of what needs to really change for that particular operation, and you're just resetting everything. Because it's so difficult to actually keep hold of what needs to happen that you're now like kind of desperately trying to, you're kind of trying to settle your application into state where it kind of makes sense. But because you don't have clear control over these values and your transitions are not clear, what happens is that you're not able to understand the edge cases of these state transitions. And a lot of times everything works on the paths that you test, but it doesn't work on the paths that you're not aware of. And then those are the paths that your users will find out and they'll report as bugs. And so part of the kind of design ideas around the API that we provide with Microstates is that so this idea of you're kind of effectively merging, every transition is you're kind of merging state into existing state. And so there is this implicit kind of what you get with set state. When you set a property, all the other properties are unaffected. So that philosophy is part of the mechanics of transitions, and it's part of how you program with microstates. But you have a lot of flexibility of how those transitions happen, but they steer you in the right direction. So you have a high chance of actually being successful longer term when you're using the application, but shorter term you're more productive.
So now you touched the subject of teaching and talking about the tool. Have you already have the experience of mentoring with Microstates, and how easy it is to learn to use it and apply it to an application, and what you think would be good to move forward in that part?
I think that so I've been using so the fundamental principles that came into designing microstates. Those principles came from teaching state management. So there's a lot of that stuff already built in. But I think one of the for me personally, the way I measure success is how long it takes for someone to feel confident. And I think one of the things that's been really interesting is because we with microstates from day one focused on marrying disparate concepts into a cohesive whole. What we're able to do is by giving like a comfortable interface, comfortable API, we are able to generate kind of a sense of ease very early on. By having like the immutability and serialization and all those things built in, they get the right mechanics like for free without having to necessarily understand them. And then what happens is that in my experience mentoring with microstates is that I will show someone a microstates model and they're like, oh yeah, I understand what's going on here. Like I don't have to explain because it actually the design, the model speaks its purpose, the transitions speak their intent what transition does speaks what will change in the model or in the state. So microstates is like abstracted high enough that you're able to declaratively convey your intention as opposed to having to micromanage the getting to your goal. And I think for that reason, I think it's what I've seen so far with my apprentices is that the ease, the sense of comfort comes very quickly. Charles, do you have any thoughts?
That's the design goal there, is to be as ergonomic as possible. And that means that, the mechanics that you work with should be self-evident. And so, by being very simple, it's actually means that there's just not that much. I don't think there's that much to actually learn. And by really, really distilling absolutely, as close to the essence of what a state transition is, and then kind of co-locating the actual values being transitioned along with the transitions themselves, and that's kind of the first piece is that co-location, which is what we're all familiar with. That's a fancy way of saying like JavaScript objects, right? Where you've got methods and the data that operates on them all right, both in the same place. And then being able to, compose those freely and say that objects are composed of other objects. Those are the primitives that you're working with. So it feels very comfortable and feels very, very natural. And so there's less to teach.
Yeah, one thing always when talking about those concepts of like atoms and how you change them, and they're like entities and they're not the values themselves, because usually when we think about mutable objects, we think about this like everything is together, right? Both the data and the behavior. I believe that it's impressive how in the React community, it's actually easier to talk about immutability than other like when a React dev, even a junior dev, already has some like immutability inside his head, because you're already doing with set state and not mutating by hand a piece of data. So yeah, it's interesting. Probably microstate is going to be easily understandable even more by people who have a little bit of experience with React itself.
Yeah, microstates comes out of in the same way like Charles mentioned about the experience in the Ember community. A lot of the motivations for building microstates was realizing the limitations of the mutable APIs that are exposed by frameworks like Ember and Vue and even Angular. So I think there is for people like I do believe that there is actually an equal benefit or potentially even greater benefit for users outside of React community. There's going to be different benefits for every framework because of the depending on what kind of APIs they expose. I think there's definitely something for everybody in microstates. And one of the things that I'm kind of most excited about is that once I'm hoping that people are going to become interested in microstates and start to want to create solutions that we can share, so that we can then start talking about what can we build on top of this, but do it in such a way that it's framework agnostic. Because right now it's kind of hard to have conversations that are framework agnostic, because there are very few things that are really common to all the frameworks. The only thing that's really common is like the component. The responsibility of a component is common, but the implementation of the component might be different according to the framework. And so that leaves very little like cross-framework collaboration. And I'm kind of hoping that microstates can become a foundation for that, where we can actually have conversations about the needs and solutions that can apply to all frameworks. And we can give us a language to talk about solving problems in different frameworks.
Yeah, I think kind of the litmus test there, I think that I would be wanting to see is, would we actually be able to distribute state via NPM in the same way that we distribute components? So it's very common. One of the things that's awesome about React but pretty much every framework has this, you can distribute, you can extend the view layer. You can extend your application just by downloading components off of NPM and then rendering them inside your application. But what's kind of out of reach right now is the idea that we might have the state machine for an autocomplete component, for example, and that state machine is available in NPM. And if I'm, if my company has some of its code is deployed in React applications and some of it's deployed in Vue applications, I can download that autocomplete, or I can NPM install that autocomplete state, and then I can wrap the view specific to my framework around it. And that is something that is absolutely possible. It's something that we haven't seen yet, but I think that Microstates is our effort to make that a reality.
Very cool. Is there a way to test microstates?
Yeah, microstates, and they're extremely testable because it's really easy because microstates essentially is just a JavaScript object. And so one of the things I need to update this, I have a to-do MVC app that is, we have a to-do MVC model that we bind to React, Vue, and to web components. And so the model by itself is actually tested separately, unit tested, just in Node outside of these frameworks, and then this model API is consumed across different frameworks. So because of the way it's atomic and because it's immutable, it's actually super easy to test. You can create a microstate instance object, invoke a transition, and then assert on what are the values that microstate assumed. There might be actually a plug here, if you don't mind. Frontside has been working on a library, on a tool called Big Test for acceptance testing applications. So it's a different layer of testing. So as opposed to being unit level testing, it's testing what the user interacts with. But I think that's the other, so there's the unit test layer, which is you can test whether, you can use something like Jest for that. You can assert on whether the model gives you the right state, depending on the transition. But then the other layer that you really want to know is, if I bind my microstate to some DOM in my framework and I click on a transition, or if I click on a button, does the result match what I kind of expect from HTML perspective? And that's what Big Test does. It's kind of the other piece of the puzzle for testing both microstates and just testing applications.
Nice. Anything else that we should jump on here before we go to picks? Any other areas that you think people might be interested in when it comes to microstates or microstates with React?
I think the biggest part is, at least for me, I'm really interested. If someone is interested in this, if they're interested in the ideas of these things, we're interested in having conversations with these people because we've been designing this for everyone for the last 2 years, and I think now the time has come for us to be able to have conversations about it. And so, if anyone is interested in this, we're very eager and open to talk. And if there's companies that are interested in if they have big enough scope where they have either large applications or many people working on their teams, microstates could be a way to really boost the productivity of their teams. And we would love to talk to companies like that as well.
Cool. All right. Well, let's go ahead and do some picks. Is your job search stuck? Maybe you're not getting any interviews with employers, or maybe you are, but no job offers. Or you may be new and not even know where to start. This is Charles Max Wood, and I'm releasing a new course and ebook on how to find a job as a software developer. The course walks you through the process of finding the types of companies you want to work for, getting their attention, and putting your best foot forward as the candidate they want. I've coached dozens of developers in looking for jobs and have been able to help several people find jobs within 2 weeks to 2 months. So whether you're new to development, can't find a great job that fits what you want, or are looking for remote work from an area without a strong tech community, I can help. Go to getacoderjob.com and sign up today. Lucas, do you have some picks for us?
All right, my pick today is not going to be dev related, but it is. It's a shout out to all devs. Take care of your health. It's really good for your development capabilities. A really good night of sleep makes wonders to your code. One thing that I've been doing lately is martial arts. I entered jiu-jitsu class. It's so good for our body, so good for our mind to just go there and empty everything. And when you go back to your code, it's like sometimes it feels like magic. Like sometimes after you work out and you are like, oh my God, then you go back to your code and things untangle. Be careful with your the way you eat, nutrition. That's my pick for the day.
Awesome. I'm going to jump in with a pick, and then we'll get some picks from our guests. I've got a couple things that I just want to shout out about. One is the Framework Summit. I'm going to be speaking at that in October. I'm going to be speaking about Stimulus, which is a framework. It's a smallish framework made by the folks at Basecamp, the folks that make Ruby on Rails. Yeah, so I'm excited about that. It'll be kind of in my own backyard here in Park City, Utah. And really, really looking forward to that. I think it's going to be a lot of fun. They're going to have the core teams from all the major frameworks. So Angular, React, Vue, Elm, Ember. Yeah, they're all going to be there. So it should be really fun just to be able to interact with all those different folks. And then the other thing that I have going on that I wanted to shout out about is I have been working on this course, and I've kind of sent rough drafts to a bunch of people who have paid me for it in the past. But I went to Podcast Movement last week, and I kind of got inspired to turn it into an ebook. And so I'm going to do the ebook, and I'm going to release final versions of the videos for the course, and it's on finding a job. So what I find is that there are folks out there that are brand new that don't know how to do a job search, or they're out there trying to find a job, right? And they're not getting called back for interviews or not getting called back with job offers. There are people out there who went through a boot camp or, had some mentor that helped them get their first job, and they're not sure how to get that next job where they can level up. And then there are people who live in remote areas that don't have a strong tech community that will provide them with a lot of options for jobs. And so this is geared toward people in any of those situations. Or if you're really experienced and you just kind of want to see what my recommendations are, you can get it as well. I'm doing a pre-launch in August. And so if you buy the book or the video